We're looking at question 95 on the AP midterm review, and in this one we're told use scenario 614. We'll talk about that. First off, that scenario does tell us that we have a probability of improperly placed bottle caps of 0.05. We also had a random variable let x equal the number of caps improperly placed. So that's the scenario from 614. Now, the rest of the problem says if you randomly select 20 bottles from those produced by the machine, what is the approximate probability that between 2 and 6 inclusive, now that word inclusive means including the numbers 2 and 6, have been improperly applied. So what am I trying to find here? Is I'm going to kind of outline some of the information. Is I'm told randomly select 20 bottles, that is n equals 20. And I'm asked to find the probability between 2 and 6 inclusive. So that means 2 less than or equal to x less than or equal to 6. So that's what I'm trying to find with a probability of improperly being placed as 0.05. So that's the information. So what I have to ask myself now is, what am I dealing with in this? What type of distribution am I working with here? I have a set number. There's 20. Each bottle cap is improperly placed 0.05 as its probability. So it has a fixed probability each time. It has a number. I'm trying to figure out how many between the two, what's the probability of 2 and 6. So I'm thinking this is binomial. At success or failure, it's either placed down properly or improperly. The probability of being improperly placed is 0.05 out of 20. I'm looking for a count between 2 and 6 inclusive. They are independent of each other. So if I look at this, I'm really dealing with a binomial where n is 20, p is 0.05, and the k is going to be 2 less than or equal to x less than or equal to 6. This is a little weird, so I'm going to actually draw this out. That'll make it a little bit easier for me. So I went through and I actually looked at the entire scenario. So if I have the 20 bottle caps there, you can see I have 0 to 20 that can be improperly placed, and we want to find that green area. We want to find the probability that between 2 and 6 inclusive are improperly placed. So I just want to find what is that probability between there. And that's a little difficult. Now I can do binomial PDF, or I can do the binomial formula 4, 2, add 3, add 4, add 5, add 6. That's going to take some time. What I can do is I can think of it very similar to how we've dealt with normal distributions when we had between two numbers. Is what we're going to do is we're going to find the area or the probability to the left of 6. Then we're going to subtract the area to the left of 1. That will give us the 2, 3, 4, 5, 6 area, or the probability. So that's really what I'm going to do. Is I'm going to find the probability of less than or equal to 6. Then I'm going to find the probability of less than or equal to 1. Subtract those. That's going to give me the probability between 2 and 6 inclusive. I'm going to use the calculator feature to help me out with this. Because, by the way, I've already addressed the distribution is binomial. I've already addressed that I have n equals 20, I have probability of success, and what I'm trying to find with the direction between 2 and 6. I've actually written down a lot of information, communicated a lot to the grader. So therefore, I can go ahead and use the calculator to help me out here. So if I use the calculator to help me out, here's what you're going to do. You're going to do binomial CDF, and you're going to take 20, your n, comma, your p, 0.05, and then how many you want, less than or equal to that number. That would be 6. So if I label that I have n of 20, and I have a p of 0.05, and I have a k value of 6, and when I write down binomial CDF, if I label those, that counts. And it's the same thing for the other one. I'm going to subtract binomial CDF, 20, 0.05, 1. Again, if I label, this is my n, this is my p, this is my k, that counts. If I type those in my calculator, I'm going to get 0.264. And if I look at that, you can see up to the side, that's probably going to be my answer for B. So if I type in those in, be a little careful here because it does look a little intimidating. 0.99997. Wow, that means you're probably going to happen at that point. And then you have 0.073584. You do subtract those after you type those in, and you get 0.264 as your answer, which is your answer of B. So this one was a really good one because it dealt with binomial. It got you familiar with binomial CDF in the calculator. And really you could see as when we deal with a lot of information like this, and we're trying to find area between, we kind of just draw it out with numbers to see what do we do. And that allowed me to see the setup. That I'm going to do area to the left of 6 minus area to the left of 1, including those numbers, and then I'm going to subtract them and get my answer. So my answer is 0.264.